Hey everybody, welcome to the video where you're going to learn all about the answers that you needed. So this is the answer key video. This is going to have all experiment 4, 5, 6, 4, 5, 7, and part of 8, I suppose, since it's technically not going to be due today. I'll give you the pre-labs for 8. So here we go. Remember, it's recorded. It's going to be a list of answers so that you guys can study for your exam. Okay. Let's go over these answers. Now, every one of these is set up the normal way. I think, I can draw. This is just going to be products over reactants. Question 1, carbon dioxide and hydrogen over carbon monoxide and water. Not raised to any powers. This is already balanced. You guys knew how to do most of these. The only time anyone got anything wrong on here was question 2, because there's only a single arrow, not a double arrow. So this was one that is not at equilibrium. This one here, chlorine and carbon monoxide over COCl2. Number 4, H2 and I2 over HI squared. Here, PCl5 over PCl3 and Cl2. 2NO over N2 and O2. Sorry, NO squared over N2 and O2. Here it asks what direction the shift would happen. This one would shift to the left. Question number 8, this one would shift to the right. Question number 9, this one would shift to the right. We remove a product. Nitrogen gases would shift to the left. We're removing a reactant. Now, in terms of post-lab, I don't think there were any post-lab questions for experiment 4 pre-lab. Now, there were a lot of questions on the actual lab itself. Equilibrium type questions, I'm kind of looking over them on the side here. But I don't see anything that stands out to me as something that you might be asked. Remember your normal Le Chatelier principles. Again, you should be good on these. Actually, there were questions that talk about if a equation evolves heat, is it exothermic or endothermic? You guys should hopefully know that if heat is a product, that it is exothermic. If heat was a reactant, then that would be endothermic. Still looking at the questions for experiment 4. Yeah, no, I don't see anything on here. Okay. 5 was more something that had like questions that we could look at. So let's look at 5. All right, write the chemical equation and the mass action equation for the equilibrium being considered in this experiment. Okay, so I think I'm going to have to maybe shift to, see how many questions are there? 4 questions? Let's do whiteboard. Write the equilibrium expression for the experiment, for the equation being worked on. In this case, it's the indicator, protonated form, and non-protonated form, so KEQ. Indicator, acid concentration, hydronium concentration, indicator concentration. Question 2, how is color used to measure concentrations? Here you want to mention that the color is related to the wavelength that it absorbs. If it absorbs a certain color, we see the colors that are left over, the complementary colors. We see the reflected light, not the absorbed light. The intensity is also directly proportional to absorbance. So that would be, I guess, how bright, or how dark the light that's coming off the solution. This has to do with, again, how much light's being absorbed. It's directly proportional to absorbance, and it's directly proportional to concentration. And we have that famous, I guess it's not that famous, we don't really know what all of these stand for, path length, absorptivity, and something else. Beer's law. Question number 3, how is transmittance related, or percent transmittance related to absorbance. You could say absorbance is equal to the log of the inverse of the transmittance. It's also equal to the log of 100 divided by the percent T. That's all you have to say on how they're related. You could also talk about it more generally. Any light that's transmitted through a sample wasn't absorbed, right? So the amount absorbed is inverse of the amount transmitted. Question number 4. What is the KH2PO4 used for? I don't think anybody got this wrong. It's a buffer. It resists change in pH. Oops. That's what it is. There we go. Okay, post-lab. Experiment 5, post-lab. Trying to think if there were a lot of post-lab questions here. Oh yeah, no, the post-lab questions here had to do with your guys' calculations. Remember, they were just adjust your pH and then recalculate KEQ. Adjust your absorbance, recalculate KEQ. So experiment 5 didn't have a lot of post-lab questions. All right, experiment 7. All right, here we go. We get some answers. We can rattle off some answers here. Okay, question number 1. 10 milliliters of this solution added to 50 of another hypothetical acid. What is the new concentration of the NaA and HA in the solution? So chemical equation, and they want the, I guess I could go whiteboard for these. So you would have to pull up your pre-lab questions to kind of look at the questions while I just give you answers. But the answer to number 1 is that the HA concentration is now 0.1. The NA A is 0.3. Sorry, 0.03. And the equilibrium expression, they asked for that. Write the chemical equation. Oh, the chemical equation. NaOH plus HA is NaA and H2O. I think that's the only one that we could really write. The neutralization. Okay. Question number 2, experiment 7. State and explain Le Chatelier's principle. Shouldn't be too hard. You can say when stress is applied to one side of an equation in equilibrium, the equilibrium shifts to relieve that stress. You could also say adding a reactant or removing a product shifts to the right. Adding a product or removing a reactant shifts to the left. Question 3. Question 3 in the post-lab of experiment 7 says, a 0.13 molar solution of a weak monoprotic acid has a pH of 4.11. What is the Ka? So here you have to, start off with your ionization. We know the pH of H+, right? In fact, I probably set up most of these problems for you already when we did that past video. This is answers. So the answer to this, you're looking for the Ka, is 4.6, 10 to the minus 8. Question number 4. 0.22 molar solution of a weak acid is also 0.14 molar in its conjugate. The pH is 5.11. What's the Ka? You have everything here except the pKa to use Henderson-Hasselbalch equation. And then when you get your pKa, turn it into Ka. The answer here is 4.9, 10 to the minus 6. So when you're doing that problem over again, that's the answer you should be getting. Okay, that's the pre-lab. Let's just jump right into the post-lab questions. So experiment 7 post-lab. Couple of questions. First one says you have a pH. Experiment 7 post-lab. Number 1. pH of 2. The pH, they want the pH. The pH of a 0.25 molar NH3 solution was measured to be 11.33. So 11.33 is the pH. you have a 0.25 molar NH3 solution. They want to know what the KEQ is. It's 1.8, 10 to the minus 5. Number 2, you have some amount of 0.5 grams of NH4Cl adding to the solution in the problem above. They want the new KEQ. Using the KEQ, calculate the new pH. New pH comes out to be 9.38. So it went down, right? Number 3, use chemical equations and words to explain the pH change. NH4Cl ionizes into these guys. Our original equation was this. So since we added this and that increased this, increasing this shifts it this way. Shifting it that way removes OH, right? Creates more of this stuff, creates more water. That lowers the pH. So that's what happened using chemical equations. You could use your words to supplement that, or you did, likely. Number 4, this is the one where they wanted you to explain the HS minus H2O. This reaction, what would happen when you add acid or base without talking about Le Chatelier's principle? Simply stated, simply if you add acid, it's going to protonate this guy and turn it into this guy. So adding acid is going to create more of this conjugate acid. Adding base is going to deprotonate this guy and turn it into this guy. So adding base removes the conjugate acid that's present and creates more conjugate base. This is what raises the pH, and why adding acid lowers the pH, because it creates more of this guy. Question number 5. What is the pH of a mixture of 15 mils 0.25 molar acetic acid and 0.46 grams of sodium acetate trihydrate? When you plug all of that stuff into the mass action equation, you use the Ka for acetic acid because it's basically, they told you the identity. You can solve for the concentration of hydronium. I'll give you that. Concentration of hydronium is 1.95, 10 to the minus 5. So the pH is 4.71. Number 6, last problem in the post lab of experiment 7. Here they ask you to do something similar. What's the pH of 15 mils 0.25 molar acetic acid and 5.3 mils of 0.18 molar sodium hydroxide? So you're basically neutralizing and then recalculating the concentration. You get a concentration of hydronium ion 5.29, 10 to the minus 5, with a pH 4.28. All right, so that's experiment 7. Now experiment 8, I think also gave you some pre-lab stuff. So let's take a look at that real quick. How many millimoles can be, or how can millimoles be calculated for molarity and volume? Basically, it's just a different, because whenever we calculate, let's see, well, millimoles is only different from molarity or moles because we're using milliliters instead of liters. At the end of the day, if you're using molarity, then all of your volume units are in liters. If you're using, if you're using moles, then it's all in liters. But if you're looking for millimoles, everything's in milliliters. As long as all your volume units are the same, they all ultimately cancel out. So you can get the same answers by using milliliters instead of liters because you're working in millimoles. What is meant by quantitative transfer? That just means when all of the weighed out sample is transferred to whatever desired vessel, and any remaining particles that are left get rinsed out, back into the final vessel. Question 3 says, in this experiment, pH is standardized against 2 buffers. What are they? It's buffers of 4 and 7 for the strong acid, strong base, and weak acid, strong base, and 7 and 10 for the weak base, strong acid. Question number 4 says, if a formula, if an Excel sheet has a reference that has dollar signs like $G, $2, how does it differ from the same reference without the dollar sign? When this cell gets copied, right, and pasted into other cells, the new cells will always refer back to cell G2, or to the absolute reference G2, where any other cells that don't have that $ in them might refer back to a different cell. So basically, $ mean absolute reference, and non-dollar signs don't mean absolute reference. All right, well, that's all of the answers to the pre-lab and post-lab questions for experiments 4, 5, 7, and 8. So, when you're reworking those, try to getting those answers. When you're studying those, think about the answers that I've just given you. And remember that lots of these questions show up again on the test. All right, hope this was useful, or hope this was helpful.